Okay, we've had some videos now concerning combination hyperbolic and trig functions, dealing with those. And here we have a problem. If the tangent of x over 2, if that's equal to some value of the tangent of A times a hyperbolic tangent of B, then in general, the tangent of x is supposed to equal the sine of 2a times the hyperbolic sine of 2b divided by 1 plus the cosine of 2a times the hyperbolic cosine of 2b. And here we have tangent of x, tangent of x over 2. I think the first thing you want to do is express this in terms of this using a trig identity. And remember how it works, that the tangent of a plus b that is equal to the tangent of a plus the tangent of b divided by 1 minus the tangent of a times the tangent of b. Now, if we had then the tangent of x over 2 plus x over 2, that of course would be the tangent of x over 2 plus x over 2, and that would equal, going by this formula, the tangent of x over 2 plus the tangent of x over 2. So you have 2 times the tangent of x over 2 divided by 1 minus the tangent squared of x over 2. So this here is the tangent of x, expressed in terms of the tangent of x over 2. So let's use this. If the tangent of x over 2 is this, then the tangent of x that equals 2 times the tangent of x over 2. So the numerator would be 2 times this. The tangent of A times the hyperbolic tangent of B divided by 1 minus this squared. So let's make some room. Tangent squared of A hyperbolic tangent squared of B. And in our final step, this has hyperbolic signs and sines and cosines. So let's rewrite everything in terms of their basic definition. As a first step, so this would be 2 times sine of A over the cosine of A times the hyperbolic sine of B over the hyperbolic cosine of B. And then down here we'll have 1 minus sine squared of A divided by the cosine squared of A. And here we'll have the hyperbolic hyperbolic sine squared of b divided by the hyperbolic cosine squared of b. So we really haven't done anything yet. We just kind of recast this in terms of their basic definitions. But what we're tempted to do is go ahead and perform this subtraction here, because we would have this minus this divided by this cosine squared a hyperbolic cosine squared b, which also appears up here, so we can invert and multiply, and that might simplify things for us. So let's see, this will be equal to, the numerator for right now just stays the same, 2 times sine of a hyperbolic sine of b divided by cosine of a hyperbolic cosine of b, and here we'll have cosine squared a hyperbolic cosine squared of b minus sine squared a times the hyperbolic sine squared of b divided by this cosine squared a hyperbolic cosine squared of b. So we can take this and multiply by this inverted. So this will equal 2 times sine of a hyperbolic sine of b divided by cosine a hyperbolic cosine of b. This is just the numerator, multiplied by, invert and multiply cosine squared a hyperbolic cosine squared of b divided by this hyperbolic squared of b minus the sine squared of a hyperbolic sine squared of b, whoops, we forgot our h, squared of b. Yes. Take it all the way across. And this is going to go away then, to take that out. So let's see, what do we have now? This would be equal to 2 times sine a cosine b. Sine a cosine a times hyperbolic sine of b times the hyperbolic cosine of b. And then down here we have cosine squared a from the denominator, hyperbolic cosine squared b minus sine squared a hyperbolic sine squared of b. Now, the numerator is starting to look interesting, because we're supposed to have sine of 2a times the hyperbolic sine of 2b. That is the sine of 2a. Remember our identity. And also it turns out that the hyperbolic sine of 2b equals 2 times, just like its trig counterpart. Except we don't have 2. We have the 2 for this, but not for this. So let's multiply top and bottom by 2. Then we have this. That's the sine 2a. And then we have this, and that will be the hyperbolic sine 2b. So that would take care of the numerator. Then we still have this down here in the denominator to take care of. And this expression here, they want in the denominator, is supposed to come out to be equal to this. So we still have more work to do, but so far the numerator has fallen into line. Let's see, I don't know if we're going to have enough time in this video to finish this off. Let's come back in the next video and see if we can get the denominator taken care of. So come back and let's see if we can get this problem finished.